Hi, everyone. Welcome. This is the Oracle Autonomous Database Learning Lounge. I am Marco Seracibia, part of the product management team for Autonomous Database. And today we're going to have a very, very cool session. We're going to be talking about our migration part 1. This is a series of migration sessions to understand how easy it is for you guys to migrate to Autonomous Database, right? So today's session, we're going to be actually talking about the Oracle Estate Explorer, right? So we're going to have Simon Griffiths and Paul Brankin, and they're going to be actually talking to us about how the Oracle Estate Explorer is this very, very interesting free tool that does, a very good analysis of your estate, right? And allows you to understand the large estate and identify the easiest and best databases to migrate to the cloud, right? So on that process, it actually evaluates the capability and how easy it is to migrate that particular databases into Autonomous Database. And it makes use of the elasticity and the capabilities of Elastic Pool that Autonomous Databases have to bring that into a database for consolidation, right, into Autonomous Database. So throughout the session today, we're going to distribute links to you guys using the chat. But if you have questions, please type them in the Q&A in Zoom, okay? And the recording and also the slides are going to be available through that link later in the week, okay? Speaking of links, I'm sharing these links now with you. So these links actually take you to our Getting Started page, our social media accounts, but also on ways on how you can make and ask your questions, right? So in particular, our Oracle Developers Workspace in Slack, you can actually ask your questions. If you look for, if you register using the link there and you look for Oracle Autonomous Database, then we are going to be able to see your questions there as well, okay? All right, so for the next sessions, we have a very busy set of weeks here for November. So on Thursday, we're going to have this same session here that we're doing today, but in Spanish. So Juan Mikalev is going to join us, and we're going to do that session there, okay? Now, next week, we have part 2 of the migration session. So we're going to be talking about OCI DMS, right? The data migration service that is going to show you how easy it is for you to migrate even an older, a previous release database into Autonomous Database, right? In a very few clicks, you're going to be able to do that. So we're going to see that session next week, right? And then on Thursday, we're going to do a graph RAG capability, right? So, bringing the power of graph into generative AI, okay? That session is going to be next Thursday, okay? And we're going to continue and have that session in Spanish as well the week after, okay? All right, so having said that, thank you, Simon, and thank you, Paul, for joining us today. I really appreciate it. So I'm going to stop sharing and let you guys start sharing, and please take it away.
Thanks very much, Marcus. It's great to be here today, and thanks to everybody who filled in the poll. The polls actually give us a really good idea on how to position the discussion today so we can address most of you. And I can see that most of you, I think 52%, I'm familiar with both. So we can start off from some basics. And so that's what I'm going to do. So today we're going to talk about Estate Explorer. Now, if you may already have seen the Learning Lounge from last year when we did an initial introduction to Estate Explorer. And today what we're going to do is really build upon that. And we're going to give a quick overview of what we said last time. And then we're going to drill down into some more detail, especially around the sizing aspects and a little around the TCO, and give you some a view on the new features that have come out in the last couple of months, which really focus on that area of being able to build what your estate looks like in the cloud. So what are we all about? So what does Estate Explorer do? So for those of you with lots of Oracle databases, you'll know that it's difficult to manage them and it's difficult to keep track on what they're all doing. And the larger estate that you have and the more lines of business that you are managing the databases for, it becomes much more complex. So the idea of Estate Explorer is to enable you as DBAs, infrastructure people, or somebody in a CIO team to get a view of your entire Oracle database estate that you've probably never seen before. So we build an inventory of all the databases that you have, and we can take the information from pretty much anywhere, whether it be Enterprise Manager or a configuration management system, or even if you've just got a list of the databases, we can accept all of that or multiple of those into the inventory. And then what we do is we visit all those databases and do a very lightweight set of queries, bring it back into the application, and then allow you to visualize that estate in many ways. And I've got one visualization on the screen there, which I'll talk about in a minute. Critically, what we try to build into the tool is for the state to be viewed in both what we say a technical and the business context. What we mean by that is that not only can you look at it in terms of the version and the size of the databases and everything else, but you can also see whether it's in a particular data center or belongs to a line of business or whether it's production or development. So all of these characteristics can be viewed inside the tool, and you can combine those with the versions. Now, once you've built that inventory, obviously what you do with it, so what we then enable you to do is to be able to look at that estate, to start to prioritize and order the databases for when you move to the cloud, and also to help choose which of the cloud service targets you wish to go to, whether it be autonomous database or Exadata dedicated or whatever. So the idea is that we help you and guide you into choosing the right destination and enable you to prioritize within that so that you can choose, for example, the quick wins. So it also helps optimize that deployment, and especially with autonomous database, which has some areas which require some small changes to be able to get to autonomous. So we help you identify those so you can look at to see exactly how complex or simple it is to get a particular database to autonomous. So as I mentioned, this works in 3 stages. We build that estate catalog, and then we plan the migrations by building groups of databases, and then we assess all those databases in the groups. And then on top of that, we're going to build the business case and the financial model around that. And so what we're going to talk to you mostly about today is this 3rd step, and especially the new capability that we have around visualization of elastic pools. And I'll go into that in a little bit more detail in a moment. So just a quick overview of what we have within the tool itself. So we have this graphical view of all of the databases. Each of those pie charts is customizable, and you can add new pie charts and remove them, and really allows you to analyze the database estate in pretty much any set of dimensions that you wish. The cluster view, we think is quite unique to this tool. We haven't seen it anywhere else. It builds a force-directed graph for those technical people who are on the call of all of the database links. So each circle here is a database. Each line is a database link between a database and another. And what we see in this is it reveals patterns and relationships between databases in your estate that you may be unaware of, or maybe created at a very low level as a database link. Very difficult to visualize those dependencies without a tool like this. So for many of our customers, this gives them something which they've never seen before, and it's really quite insightful about how those databases are linked together. And for example, we can then select one of those clusters of databases and then create a group, and then we can do an analysis directed around that particular cluster. Now, once you've got one of those groups of databases, the question is, well, does it make sense to move that to cloud? And so what we have built into here is a fully customizable TCO model. So it looks at the total cost of operation of that group of databases, and then compares that with an on-premises cost and with the target environment, be it mostly Exadata or autonomous. Now, obviously, as customers, you have very different types of cost and different levels of cost for the different, for example, for DBA costs or infrastructure costs. So the model itself is customizable, so you can go in and put your own parameters in this and work out whether the TCO works specifically for you. As I mentioned, we also assess for autonomous database. There are some areas of autonomous database which require some small changes. For example, database links are handled slightly differently with credentials and so on. And so what we help you do is identify those changes that will be required to a database. We list all of those, and we allow you to assess and rank the databases by how difficult or easy it is to migrate to autonomous database. What we tend to find most recently is about 70 to 80% of databases can migrate to autonomous with very, very minor changes. And as we go on with autonomous database, we're trying to get that down as far as possible. But obviously there are some constraints which we put in because a cloud environment needs to be fully secure, whereas with an on-premises environment, it's a little bit more open to yourselves as customers to configure in different ways. So this is the new part that's actually only been out a couple of months now. And I'm not going to go into this in detail. I'll leave that until the demo a little bit later. But it looks at the workloads that you have on premises, grabs the metrics, and then models that inside an Elastic pool. All of these are available via the UI, but we also have a set of PDF reports. And if you are DBAs wanting to discuss with end users, to discuss with application owners, these are a great mechanism so that you don't have to give everybody access to the app. You can produce the PDFs and then move them around your organization and share them across different business units. And this was a customer demand where we built this in, and it's very successful at helping you have those discussions internally and building the case for moving to cloud. And just while I'm here talking about cloud, of course, we used to talk about OCI, but now we don't really mind where you take the database. We'd love to be OCI, but we're equally happy with you going to Azure or Google or more recently AWS. Okay, so I'm going to go quick reminder to start off with on how we do autonomous database sizing and some Elastic pools. And since many of you haven't heard of Elastic pools, that's good. So, well, how do we charge for autonomous database? Because it's a fully Elastic system, and we charge against the number of CPUs that are allocated. Now, as your CPU goes up and down, you still get charged for whatever you have allocated. Now, of course, if you wish, you can reduce that allocation and increase it manually or via scripts, but essentially you get charged for what's allocated throughout the life of the database. We also have a facility called auto-scaling, which again, you have an allocation of CPU, but differently with auto-scaling is we also allow you to scale the eCPU up above that allocated level. And then you're only charged for the incremental CPU that you use above that base allocation. It's a fairly complicated algorithm. So we measure eCPU by every single second. We average that over an hour, and then you get charged for those blocks. It's, as I say, it's a little bit of a complicated algorithm, but more or less it works out as a very effective way of being able to have extra CPU and only pay for what you use. Now, there's another aspect of autonomous database, where sometimes you need more than you get allocated by default with autonomous database. We typically see this with a small percentage of databases, which maybe it's an ISV app, which opens thousands of connections to the database, but they remain unused. Sometimes we have some applications which require very high memory. Much more rarely we have applications which need extra I/O. But whichever one of those that you need, we can allocate more eCPU. Even though you don't strictly need that CPU, we can allocate them, and that gives you that extra memory, max sessions, and eCPU. So you get charged for the full 7 eCPU to get that extra memory sessions or I/O, but we only but then there's some unused eCPU capacity. And this is, I'm going to reference further on now. So this is where Elastic Pools comes in handy, because we can help you use that eCPU capacity with Elastic Pools. So this is where we come into thinking about groups of databases. So Estate Explorer itself is really focused on large numbers of databases. We normally say 50 plus, but it's really, if you have a number of databases which is at least the size of a Elastic Pool, which is 128 eCPUs, it makes sense to use Estate Explorer, and certainly for larger than that. So here's a group of databases which I've mocked up, and the idea here is over time those databases go up and down in their eCPU requirement, and then you've got this is a stack graph, so you've just got that aggregate CPU usage on the top line there. And on the left-hand side, you've got the number of eCPUs. So to be able to accommodate, so if they've got very high I/O or very high I/O memory or sessions, you may have to allocate, in this case, we said 448 eCPUs to be able to get that level of memory and sessions. So there's some unused eCPU there. So that's what happens if you don't have elastic pools. So this means that for you who are consolidated onto the cloud, this is not a good story for you. But elastic pools actually transforms the story into something which gives you major cost savings, even compared with on-premises. So a reminder about what elastic pools are. So in general, it's a group of databases that are pulled together just for billing purposes. We don't move them. They're just groups, and we can pull databases in and out of an elastic pool in just a few seconds. An elastic pool has a basic size of one of those numbers there. So what we do as an Oracle is we take the eCPU from multiple databases in the pool, their hourly usage, and then we put it into a pool billing algorithm, which I'll explain in a moment. Now, the other thing about a pool is that we have a basic size, and that gives you the amount of eCPU, but we actually allow you to over allocate, in effect, up to 4 times that number of eCPUs. So, and I'll go into that in a moment. But as we then bill, if you only use the smaller amount, the base level of eCPU, that's all we charge for. If you use a little bit more, we might charge for 2. And in extreme situations where your databases have really grown for a particular hour, we may end up charging ×4 for that particular hour. So let's go back to that set of databases and see how it's different within elastic pools. So what we're going to say here is we're going to start off with an elastic pool of 128 eCPUs. Now we're going to create databases in there. And our databases here, you can see the eCPU graph, but we're going to allocate 448 eCPUs. And it's important to remember here that you actually get all of the memory, all of the sessions and the I/O that come with those 448 eCPUs. Now the full capacity of the pool might be a little bit more than that. In this case, I've got it at 412. But what we charge for as Oracle is nothing like that top number. What we charge for is the base amount, and only when the eCPU goes above that level do we charge a little bit more. And what that means is that all of this red stuff is consolidation savings. So this is in this particular example we've got 60%. We often see 60 or 70 or 80% savings when we consolidate onto elastic pools compared to not using elastic pools. So really speaking, if you've got 128 eCPU requirement for a bunch of databases, put them in a pool and you'll start to save significant amounts of money. Now, what we've done in Estate Explorer to enable you to drive into that and understand what the savings are is we've built a simulator to take your workload that you're running on premises, to grab it from AWR, simulate it inside what would that look like in an elastic pool, and give you some numbers. And Paul's going to take you through that just now. For those of you who want to have a look a bit more about this, we have an external website which you can click on here, and we'll make this available, this link available later. So with that, I'm going to stop sharing and hand over to Paul. And what Paul's going to do is to take you through not everything that I've just shown you, but most of the sizing stuff that we've shown at the end there. So Paul, are you okay to take over?
Absolutely. So, hello everyone. My name is Paul Brankin. I'm delighted to be able to share with you today some of the exciting sizing capabilities that we have inside Oracle Estate Explorer. So in this demo, we're going to get an understanding of how Estate Explorer uses your database's real-world utilization metrics in its own calculations to give you accurate sizing estimates for hundreds or even thousands of Oracle databases. So those databases we're going to look at can be sized for a range of autonomous deployments, such as auto-scaling, elastic pools, as Simon's mentioned, but also Exadata as well. In fact, as you'll see in the demo, you can even combine those databases to create a hybrid deployment of some databases to autonomous and some databases to Exadata. So with that, let's get started. We're looking at a database catalog for a customer with over 1,000 databases. Here we can see 1,063 databases, And we've actually created 4 groups within that catalog. So in this case, it'll be something like production, development, and test, for example. Those are the kind of groups we're looking at. But as Simon said, you can group by any criteria that you like, location or some business criteria or database versions. You can segment this catalog in any way that you like. Below this catalog, you can see some charts. And as Simon said, we can add charts to this page and remove them as we see fit. But underneath, we can see the list of all the databases in this catalog. So all 1,063 databases are listed here. We can see the name of the database. We can see that we've assessed them all within Estate Explorer at the moment. And we can see some typical sort of characteristics of the database, such as the environment it is, whether it's a pluggable database or non-multi-tenant, database version, and so on. The typical things that you'd be interested in. But the reason for showing you this page is because I want to focus in on the metrics that we use for calculating the sizing information inside Estate Explorer. So I'm going to look for a specific database here just by typing in part of the database name. And you can see that it's found 3 databases, and they are across test, staging, and production. I'm interested in the production database for this demo. So what the Estate Explorer does, it goes and gets some basic metadata here that we can see on the screen, such as what platform the database is running on, the size of the database, again, whether it's pluggable, what the version is, etc. But what I'm most interested in here is actually this CPU usage information down here in this tab. So if I click on here, I'm going to quickly go to this CPU source tab. And what this is showing me are the actual metrics that we retrieved from the database using Estate Explorer's extracts for the CPU utilization held within the AWR repository. And we will retrieve as much information as that AWR repository has, depending on the retention policy that you set up. So we can see here, for instance, we've got 2 database instances. So clearly it's a real application cluster that we're looking at. And we have, what does that look like? I think it's about a week's worth of data there. Well, a week's worth of data is probably not sufficient to use as a sizing input into an algorithm. So what Estate Explorer does is it works intelligently with the data that we have, the real metric we have here, and it builds up a profile across a month. And so you can see here that the data in black is the actual data that we retrieved from the database, and the data in blue is what Estate Explorer has extended that data set with in order that we get a full month's profile of utilization. And one of the ways it would do that would be if, for instance, we're missing data on a Wednesday at 3 o'clock, for example, it would look for all of the Wednesdays that we have at 3 o'clock and take an average of the utilization across that time slot and then say, well, we'll use that. So it doesn't just copy and paste values, it looks for averages across time slots and day slots within the entire month. And that way we can get a more full profile of CPU utilization that we can then plug into the sizing algorithms within Estate Explorer. So that's one database. And I just wanted to show you that to show you where this is coming from, because this information directly drives the calculations that I'm going to show you in just a moment. So I talked about the fact that we've got some groups inside Estate Explorer, and you can have as many groups as you like, and databases can be in more than one group as well. So you can have a mix of technical and business criteria. You can see my groups here, and I'm going to focus in on this development group. So I just click on that development group, and I'm going to click Go to Group. Okay, so what we're looking at now is a list of those databases that are specifically in this group. And one of the things I would want to do first is just make sure that any of the assumptions that Estate Explorer has made about the profiles of these databases are accurate. And I can do that by clicking on this Amend Database Profiles button here. And it takes me into this screen where, again, I see all of the databases in this group, but I can also see what type of database Estate Explorer thinks is appropriate for this workload. So ATP is our transactional autonomous database, and ADW is our data warehousing autonomous database. So it has automatically tried to give an assignment of database type to each of these databases. And I can change this if I don't think it's accurate. I can click on here and I can change it to ADW if that was appropriate. I can also see here the size of the database, and I can see here a set of information about how the CPU metrics that we've gathered are going to be used. And so I could choose for a particular database. Let's pick one down here, for example. Let's pick this one here. I could say, you know, I don't want to use these actual numbers of 0.75% for average and 16% for peak, because I know that we didn't capture, I don't know, a batch window that was particularly important to this database. So I could set this to use the estimate that I have of 15% for the average and 70% for peak. And you can change this for each individual database as you see fit. And I can also turn on and off OEE's memory consolidation capabilities, which is a way of making sure you're using the optimum amount of memory for this given database. So we give quite a lot of control over each individual database to ensure that the inputs into the sizing algorithms are as accurate as possible. So let me save those changes that I've made there, and let me go back to my group. Okay, so what we're going to look at now are the actual results that we get out of Estate Explorer for sizing. So I click on View Results for this group. And the first thing we see is actually the autonomous readiness capability of the tool. So the tool will look at all of the databases in the group, and it will look at the features that are used inside the existing on-premises database and see if there are things that are being used on-premises that need to be reviewed prior to moving to autonomous. And you can see a selection of the kind of tests that are run here against all the groups, and a score for each of them, and a count of all of the objects that were found. And underneath that, again, we get a list. This time it's a ranked list of databases with the easiest databases to move to autonomous at the top, and then the progressively getting more complicated or challenging databases at the bottom. We're not going to focus on that today, but if you want to know more information about that, please see the previous learning lounge we did about 6 months or so ago, because there's lots of information in there. So we're going to focus on sizing, and the sizing information is all under this tab here, the TCO Analyzer. Okay, so what we're looking at here, this is a TCO, a summary of the TCO, where on the left-hand side in dark blue, you can see an estimate of how much it would cost to run these 240 databases on-premise for 1 year. Okay, and this is around about just under $1.5 million. The inputs that go into that calculation are all configurable by you, so you can decide what the actual costs are that go into the calculator. They're not locked down by Oracle, so you can make sure that these are as credible as possible. But the inputs we give you as defaults are the ones we typically see across our business value team inside Oracle. So that's the left-hand side. It's an estimate of the cost to run these databases on premises per year. And on the right-hand side is the cost of running these databases, the same databases in Oracle Cloud. And we have a number of different deployment models for autonomous that we could pick. We'll just stick where we are at the moment, because I want to focus it really on this on-premises side. From the sizing point of view, how do we know about the sizing of the on-premises databases for all 241 databases? Well, I can look at that by clicking on this on-premise cohort tab at the top here. What we're looking at is everything I need to know about how Estate Explorer is going to use this information for both a TCO point of view, but also that then subsequently feeds into the sizing algorithms that are used for autonomous database and for Exadata. At the top of the screen, you can see a summary. So I can see how many databases are in this group, how many vCPUs are being used, how many cores are being used, the memory, storage, And I can also see the types of databases within the group, 221 non-multi-tenant databases and 19 pluggable databases. Underneath that are all the breakdowns of cost associated with running this on premises. We're not going to focus on that so much today. We're going to focus on the sizing. But there's a lot of information there for you to look at. Underneath the summary is a list, again, of every single database in this group, individually sized and estimated for the on-premise cohort. So I can see, let's look at the top database here. I can see that we've got 14.75 gigabytes of SGA and PGA, 445 gigabytes of storage. I can see the host. I can see how many cores are on the host and how many threads that is. I can see that this database shares the host with 36 other databases. And whilst that might seem like an awful lot of databases to share on a host, the reality is that these are all pluggable databases. So they may all just be in one container database or maybe just in a couple of container databases. But there are 36 databases sharing the resources on this host. And so in order to get an accurate estimation of CPU resources that are required to run this database, Estate Explorer does some calculations to determine whether the underlying host is overcommitted for CPU or undercommitted for CPU. And this gives us a reasonable and accurate estimation of really what is the CPU resource that's being used by these databases on premise. So that's great, and I can go down to the bottom here and see that there are pages and pages of all these databases I can scroll through and get a good understanding of them. If I go back to my TCO front page here, and I say, okay, well, let's see what that looks like if I wanted to deploy all 241 databases to, I don't know, ADB dedicated with auto scaling. I simply click on here, and pretty much instantly, Estate Explorer will recalculate both the sizing and the TCO costs for running these databases onto dedicated with auto scaling. So again, I want to see, well, what's the details behind that figure? What's the sizing that's driving that, that cost argument on the screen? So I can do that by clicking on this the autonomous cohort at the top of the page here. And again, like before, you can see a very similar layout. We can see that there's a summary at the top, and we can see the list of all of our databases that are going to be deployed to dedicated, or autonomous dedicated below that. So let's have a look at the summary. We can see that we've got our databases that are going to dedicated with auto scaling, and we can see that Estate Explorer has calculated that you're going to need 1,109 eCPUs to run these databases on dedicated. We can see that because it's dedicated, there's infrastructure involved, and so that to house those databases, you will need 3 database servers, 3 Exadata nodes effectively, and that those 3 database servers will be 73% utilized by those databases. We can also see that you'll require 7 storage cells, and that those storage cells will be 68% utilized. Now, clearly, this is an important understanding because Exadata dedicated is a fixed capacity. And so the more you can drive that usage of that capacity, the greater the economic arguments of using dedicated is. So it's not just what the cost is, it's how much have I got left to use for more databases, because I want to put as many databases in here as I can to drive the value out of the infrastructure that I'm paying for. Underneath that then, as I said, is every single database that is routed to autonomous dedicated. And again, let's look at the top line, the first database. We can see that it's running on a single database node, so we can handle rack in this environment absolutely fine. There is just 2 vCPUs in that single node, so therefore, obviously, the total is 2 vCPUs. So a vCPU is equivalent to 2 eCPUs, or to put it another way, a physical core or an OCPU is equivalent to 4 eCPUs. So therefore, if I wanted to move this database to autonomous exactly as it is, I would need 4 eCPUs. However, in this particular example, the databases are coming from a traditional x86 platform. but they're moving to Exadata. So underneath autonomous is Exadata and all of the benefits, performance benefits and more that the Exadata platform provides. And so therefore we take account for that. So we reduced, in this case, the 4 eCPUs down to 2. So that's a 50% reduction in CPU requirement simply because of Exadata's architecture and the fact that so much benefit is actually in the storage cells and the software that underpins the autonomous database. That 50% reduction is entirely configurable by you. If you don't believe it's 50%, change it to what you do believe it is. But our experience shows that that's typically what we would expect to see when moving from a legacy x86 deployment to Exadata. So you can configure that again yourself. And then we see our CPU utilization figures that we got directly from the database. We can see, remember, this is a development environment. So we perhaps wouldn't expect to see very high CPU utilization. And indeed, that's what we're seeing here. So we can see this particular database only peaked at 2.36%. So we don't actually even need these 2 eCPUs. We only need a single eCPU to drive the workload for this database. Having said that, this database does require some additional memory. So we get a certain amount of memory per eCPU, but a single eCPU is not going to be enough for this database. So we've identified we need to allocate another 3 eCPUs to get the memory that we require. We don't need any additional eCPUs for sessions because that's met by the 4 eCPUs that we've currently allocated. And so therefore, our total eCPU allocation for this database is 4. That gives us a total of 11 gig of PGA and SGA, and our storage is the same as it would have been on-premise anyway. So as you can see, for every single database, you've got that individual calculation from left to right, from on-premise right the way through to autonomous deployment. Okay, so that's great. Let's now go back to here and say, well, what if I wanted to deploy some databases to autonomous and some databases to Exadata? I can do that by moving this slider here. If I move this slider, what it's going to do is move all of the databases that are to the right of the slider to Exadata, and all of the databases to the left of it will go to autonomous. You can see I've got a couple of different Exadata models down here that I can pick, Cloud Customer and Database Service. So if I do that, I should move this to 180, or round about 180. And what I'm effectively doing is moving those more difficult databases in that list that I showed you when we first came into the page. We're moving those to Exadata because perhaps some of the things we'd have to change for autonomous would be maybe they're too restrictive, or there's a lot of effort in there, or maybe there's a support reason why Exadata would be a better target for those databases. So this has created me a hybrid TCO model here, and you can see it's more or less split in two here between Exadata and autonomous. And now if I click on my Exadata cohort, I can see the same kind of display as before. I've got my summary at the top, and I've got my Exadata databases underneath. I can see I've got 58 databases going to Exadata, requiring 132 OCPUs. That will be across 2 database servers at 52% capacity and 4 storage cells at 70% capacity. Reasonably healthy. And then underneath that, we can see the individual databases, again, sized for Exadata. This top one has 1 database node, 8 vCPUs per node on premises. So therefore, we need a total of 8 vCPUs. They are converted to OCPUs, which are then discounted for the Exadata benefit from moving from x86 to Exadata. Again, reminding you that's fully configurable. And we have, again, very low CPU utilization. Remember, this is development. So in actual fact, we only need a single OCPU to drive this database. And the memory, because this is Exadata, well, you can allocate as much memory as you have in the infrastructure that you are paying for. So we can have exactly the same amount of memory as we have on premises here. And then the storage is also as it was on premises. So what I've shown you here is how we can get a really good understanding of the sizing of our on-premises cohort that then feeds into an autonomous cohort and also an Exadata cohort. So we get a great understanding. It's the same approach, left to right, the same sort of layout and consistency across all of those 3. What I want to focus on now, though, is to show you how elastic pools is, as Simon has showed you in his slides, is something of a game changer for deploying databases to autonomous. So if I go back into the analyzer, it's already selected elastic pools down here, and we can see the cost is reduced down to just over $533,000 compared to the $1.5 million or so for the existing estimate. Okay, so let's look at the autonomous cohort here again, because it's slightly different for elastic pools. I'll bypass the summary at the top because that's more or less the same, only to point out that you have ATP databases, that's the transactional databases, separated out from the data warehouse databases because the storage and the cost of storage are different for both workload types. But let's focus on the differences in the list underneath, because there's some slight differences here that you should be aware of. So what should we pick on? Let's find an interesting database. Okay, let's take this one here, this fifth line down here. So again, we've got one node, 4 vCPUs per node. So it's a total of 4 vCPUs. Turn them into eCPUs, reduce them because it's Exadata, and it's running at 26% utilization at peak based upon what we captured from the AWR reports. So therefore, we actually only need 1.0516 eCPUs. And the interesting thing here is that because we're looking at a pool, we actually can work in fractions of an eCPU, because what you account for is the size of the entire pool, not individual database sizes. So we are actually only going to account for 1.0516. It won't be rounded up to 2 eCPUs from a costing point of view. We can also see that we need 6 eCPUs to get the additional memory that we require for this database. And so therefore we will allocate 8 eCPUs. But in actual fact, it'll only be this 1.0516 that will effectively be chargeable from a CPU utilization point of view. Okay, so this is where the 60% savings comes in, because we're getting the memory associated with these 6 eCPUs for no additional charge. Okay, so therefore we can now allocate 22 gigabytes of memory. The storage is same as on-premise anyway. And we also show on here, which is pretty interesting for chargeback reasons, for example, each individual database within the pool and their eCPU cost, storage cost, and total cost. Okay, so that gives you all the detail that you need, but a way in which we can make it clearer and be able to optimize and drive the efficiency and economics of using Elastic Pool can be done using the Elastic Pool Simulator. So let's have a quick look at that. So we have a lot of information on this screen, but let me start off by looking at the chart at the bottom. So for all the databases in this group, the 240 databases in this group, we have all the aggregated CPU utilization in a single chart. And if I zoom into here, I'll show you some of a little bit more close up, some of the detail. We can see that we've got, for every hour, we have the aggregated CPU utilization, in this case, of 240 databases. So I can see exactly what's happening hour by hour for 240 databases in a single view. And that's really important because what this is showing me is the CPU usage. And that is a key component of what size pool we need for this group of databases. You don't need to worry too much about that because the OEE will calculate this pool size for you. So in this case, it's telling us that we need a pool size of 512 eCPUs to drive this workload. So this left-hand bar chart is showing me my CPU usage for all of these databases. The bar chart in the middle is showing me what my CPU allocations need to be for all of these databases. Now you can see here that I've got some, in the blue, I've got the CPUs that are needed to get me my additional memory, and my light blue segment is actually the CPUs I need for my workload. I can click on this dark blue box here and see a list of all those databases that require additional eCPUs to get additional memory. This is important because you might want to have a conversation about whether you need that memory. Maybe there's an opportunity for reducing memory and reducing eCPU utilization still further. And to the right on the pie chart here, we can see the amount of resource that each database is consuming within the pool. So you can see that the vast majority of them are actually using around about the same sort of resources. But there are a couple of databases here that are eating up quite a large amount of the pool. So we can have a look at those in detail. I can click on the segment here, and for this one database, I can see it's using 64 eCPUs, and I can see its usage over time here. So I might want to do something about that. That might not be a good use of the pool. I can also see, let's click on the next one. And here again, I can see that 43 eCPUs are being used for additional memory here. And I might want to do something about that too. Because the reason why I might want to do that is because I can see here that there's quite a lot of green in this pool. And that green means available eCPUs for allocation. But I can also see that I'm only just over half that pool allocation. I'm only just over 1,024 eCPUs. Therefore, I've just crept into the next tier up. This is why I'm having to have a 512 eCPU pool for these databases. So what would happen if I could optimize the pool membership? Well, I can look at these two big databases here that we looked at. And down here, I can see, oh, it's this brown database here is consuming a lot of CPU resource. I can turn this off, the database off, and it will redraw the chart. And let's turn off the other one as well. This is a light brown database. We turn that one off as well. And we've got a bit more of a stable, sort of less peaky, less dynamic pool usage now. If I ask OEE to recalculate the pool by clicking on this button here, so it's now recalculated that actually now we need just 256 eCPUs to drive these 240 well, now 238 databases rather than 512. And we can see that there's only a really small amount of green on this chart, which means we are driving a tremendous amount of value out of this elastic pool. And if I go back to the TCO chart, remember it was about $533,000 to run the 240. Just by taking these two databases out, it reduces the cost down to $338,000. Okay, and therefore I might want to put those two databases on autonomous with auto scaling, for example, to drive the economics of the TCO in this case. When I'm happy with my databases, I can create a group from the pool and I can move forward to migration, and we know that we've done a good job in mapping the databases to an elastic pool. Okay, so what I've shown you today is how you can use a State Explorer using your on-premise database metrics to calculate accurate sizing when we're looking to migrate your databases to autonomous databases and Exadata. We can see that we can do it easily, quickly, and kind of in an explorative way and in a consistent way. And you see it takes seconds to play around with the options that you've got in the tool. And you've seen that by using capabilities like the Elastic Pool Simulator, State Explorer helps you drive the maximum amount of value and benefit from migrating to Oracle Cloud. So with that then, Simon, if I can pass it back to you.
Thanks very much, Paul. And I think I learned a couple of things in there as well. So thank you for going through all of that. So what I'm going to just set out last slide, really, which is just a summary of what you're able to do with Estate Explorer. Whilst maybe some of you might ask some final questions before we finish. And I think Marcus will do a poll towards the end maybe as well. So really the idea is for you as customers or partners and customers to gain knowledge of a database estate, for you to be able to select from that estate what you wish to move to cloud and in which order you wish to do that. And then you can often we look for quick wins as well. So if you're looking to run a trial or a proof of concept, how do you identify those which are easy to move to cloud and easy to move to autonomous database? And that's a key for many customers who want to give it a try, but they don't know where to start. And it's easiest, obviously, to start with a database that is very easy to migrate to autonomous. And then the final one is building that financial model. So moving to cloud does cost. Obviously, there's a migration cost. If you if you look at that migration cost as being equivalent to an upgrade, so if you're on 19 now and you wish to upgrade to 23 in the future, instead of just doing an in-place migration to 23, if you move to autonomous database in the cloud, then it's probably not that much cost, additional cost for the migration. So we're really looking at the financial model, therefore, based on the TCO. So the TCO you're seeing today will give you a good idea on whether you can operate autonomous database and Exadata at less cost than on-premises. So that's really all we wanted to cover. I hope this has sparked some of your interest. I've shared a link to the External Database Explorer website. We only release this to partners and customers because we do it as open source, and we don't really want all of our competitors to get a hold of this. And so the way to get hold of it is to contact your Oracle rep or your Oracle partner rep, and we can provide you with the download plus all the documentation and, for example, demo data as well. So if you want that, please contact your Oracle rep. And with that, I'll say thank you very much and pass over back to you, Marcus.
Perfect. Excellent. Thank you very much. Yeah, this was a great session. Thank you very much, Simon and Paul. Great session and a great demo. We've had 46 questions already. So guys, if you have more questions, please type them in the Q&A. Okay. I really appreciate it. Just wanted to check with you guys. How are you feeling after the session today? So hopefully you guys learned a lot. I know we had so many questions that it was definitely a great session. So we still have more questions coming. So I see Simon typing them in there. Again, guys, keep the questions coming. Okay, we're gonna leave the webinar open for the next few minutes, even after we finish here. Okay. So I will put again the links in chat. I know a few people asked. So I'll put the links here in chat for everyone again to make sure you guys get it. And I see people raising their hands. If you can, please type the question in Q&A. We appreciate it. So Simon and Paul are actually just answering the questions right now. Okay. One more thing here regarding the links again. I just put them there. But if you guys go back to the main Learning Lounge site, okay, that's where you're going to see some more links. You're going to see all the upcoming sessions. Okay, so make sure you subscribe to the whole series so that you see the upcoming sessions and receive the invitations, right? And then you can see the replays of the previous sessions there as well. Okay, so everything is going to be there available to you. All right, so I think that's it. Again, thank you very much for joining, guys. Really appreciate it. I will leave us with some music, but I hope you guys had a great session. Thank you again, Simon, and thank you, Paul, for the session. It was great. We'll leave these open for a few more minutes. If you guys still have questions, please type them in the Q&A. Okay? I will be listening in. Thank you. Appreciate it.
Thanks, and bye, everybody.